Hi everybody. Today we are going to talk about transistor. So we are going to take this NPN transistor and we will use it in a circuit, and then we will understand that how we can use NPN transistor with E emitter configuration, common emitter configuration in the circuit. So for this circuit we are having the given values. We are going to use an inductive device which watt is 0.70 voltage with at 12 volt, and beta is like the amount of amplification, which is the transistor gain, which is we can take it as 100. So first of all, we will see that where we will put the inductive device, because we are going to control the circuit through this base. So if we will go with we will just design the same uh, component here. As here is the base, it's the base, and this is the collector, and this is the emitter here where we will put this inductive device. For this inductive device, we can say that we will put it here. I will just make an inductor shape here, and I will just mention it here that we are giving 12 volt from this point from the collector. And at the base, what is happening at the base, we can see that we can put a resistor here just to keep our circuit safe. And here we are giving DC. Here we are giving DC 5 volts at the base, and here we are giving 12 volt at the collector, and here it is the ground. So let's see how we can identify the values here and how we can use this thing by passing through this inductive device. So what we have here right now, we just need to find out the amount of current which is passing through this, could be the IC, the passing through this inductive device. We can use this formula which we already know, power is equal to VI. Here we know this voltage, and we know this power, but we don't know the current. Let's use it in a way that I is equal to P over V. Power will be power is like 0.7 watts, and this voltage will be 12, and if we will divide it, we will get it around 0.058 amperes exactly. So we will convert it to milliamps. So then the current will be point will go here, then it will be 58 milliamperes. So we have it here. Now we have to know that we already know that we are having here at current will be at 58 milliamperes. We already know that this current, the amount of current which will pass through from resistor, which will be IB, 100 times less than this one. So how it will be happen? We know this formula here, which will be IC is equal to this factor, which we can call it beta, and IB. Then if we go with this formula, and we could around the amount of current which will pass from here, it will be around 0.58 milliamperes. So the current from B, from the base. So we can just imagine this thing, it is 100 times less current will go from here, and we already know the voltage which is passing through this thing, but we need to know that how much voltage drop is happening from base to emitter. From base to emitter, we know that we use the silicon diode, and when the silicon diode is used, then it will go with the 0.7 voltage drop will happen. So here we can also again use this Ohm's law. And according to the Ohm's law, we already know that V is equal to IR is going to be happen. And here we know this voltage, and we also know the current, but we don't know the resistor. So the resistor will be like R is equal to V over I, and voltage drop will be from this one minus 0.7. So this voltage will be 5 minus 0.7. So here it is we came to know that the current from this resistor will be 0.58 milliamperes. So what we will do, we will not just take the 50.58 milliamperes, we will round it up to 1 milliampere. Why? Because we want to keep ourselves on the safe side, and we want to keep the resistor value a bit higher from the required one to keep our this component and whole circuit safe. So we just assume we will just increase this value from 0.58 milliamperes to 1 milliampere. So here we will use 1 milliampere. Then we will minus this thing, 5 minus 0.7 divided by 1 milliampere, then it will be like 4300 ohms. It will be something like that. So we can see that what is the nearest resistor near this value which we can have. So normally we can have 4.7 k ohm resistor. So we will use this 4.7 kilo ohm resistor here for this resist RB here. So we can use 4.7 kilo ohm resistor. Now what is happening here? We already know that what will be the current passing through this. It will be like IB, and its value will be we can calculate it as 1 milliamperes, and the amount of current which is flowing from top of this till the end, it will be IC, which will be around 58 milliamperes. So this is the final thing which we already know, that how much amount of voltage or resistor which we will use here, and how much amount of current which will pass through from IB and from IC. Now we need to know that what will happen when we turn off this circuit. So when we turn off this circuit, then what will happen on this conductor, on this inductor, we are going to have a very big amount of magnetic field right now. So when we will turn it off, then if the amount of magnetic field will try to collapse here, and due to the collapse, a big amount of at this point we are going to have a very high voltage which can damage our circuit. So to save our circuit from damage, we will use a clamp diode here. Clamp diode will be something like this. Its direction towards will be towards up. So that big amount of voltage will be go through this diode and go to this point. And just to smooth that big amount of voltage, we will use a capacitor on this thing. So we will use this capacitor. We can just assume it at 0.001 microfarad capacitor will be enough. So what will happen when the circuit will turn off? A big amount of magnetic field, due to the big amount of magnetic field, a huge amount of voltage which will rise here, it will go through this capacitor and it will get smooth. So not very high sharps will come, peaks will come, and then it will pass through this diode and the circuit will be saved. So in this way you can use this NPN transistor in the circuit. So you can see that by having just two values, 12 volt at the collector and 0.7 wattage of this component, we already know all the other components in the circuit. So what will happen that if I have some other circuits which I need to explain in next videos, I will make it a bit more devices in each circuit and I will explain you in this way. Thank you for your time, and you can also share, comment and like these videos.